Good morning, Professor Q. My name is LV, and together with me are my group mates, Benjamin Lee, Benjamin King, Justin, Jia Sheng, and Kenneth. We will be sharing more about our project, which is the use of IoT in residential homes, especially the kitchen. The scope of this project includes background, our proposed solution, our component, our key innovation, challenges, and finally conclusion. According to research, the top 4 kitchen hazards are burn, slips, trips and falls, cuts and laceration, and lastly, fires due to unattended cooking. The percentage for fires due to unattended cooking is the highest with a percentage of 40.4%. In addition, HDBs built before 2018 do not have smoke detection systems in place, which also results in one of the causes leading to huge fires in residential homes. With grease buildup slowly accumulating due to constant cooking, it also promotes the risk of flash fires. This brings us to our problem statement, which is unattended cooking and poor kitchen hood maintenance are major causes of kitchen fires. Hence, there is a need for an IoT solution to detect fire risks as well as to alert occupants to grease buildup to prevent fires. Our solution will be to implement an IoT solution that can automatically shut off the stove in an event of a fire alongside the detection of grease buildup. This allows the user to know when there is a need for maintenance. Next, Benjamin Ching will be talking about the components elaboration.
Thank you, LV. Next, we'll move on to the component elaboration. Together, we have 5 components ranging from an LED, buzzer, temperature sensor, and a servo motor to an LCD. The 5 components work hand in hand to achieve its intended function. For LED, it flashes light to alert the users when the temperature exceeds the threshold. For the temperature sensor, it tracks temperature in 3 levels: a standard room temperature, a general operation temperature, a hazardous temperature. For light sensor, it's used to track the intensity of the light in the film hood and its cleanliness. For LCD, it displays the temperature as well as cleanliness of the film hood based on the value taken from the light sensor. The buzzer will sound when the temperature reaches a threshold for the temperature. Lastly, for the actuator, it will turn off the stove when the temperature reaches the hazardous level. Now Justin will tell you more in the next slide.
Next, I will be sharing more on the growth temperature sensor. The sensor is responsible for detecting unusual heat levels that pose a fire risk. It provides real-time temperature data, enabling the system to shut off the stove automatically. It helps to reduce the risk of kitchen fires, which ensures safety by addressing the fire hazard immediately. Component will be the servo motor. It acts as a fail-safe mechanism and will be activated once the temperature spikes to an unusually high level. It shuts off the stove, preventing the fire from spreading, acting as an additional safety layer for cooking. Followed up will be the light sensor. It is responsible for detecting grease buildup, and it can measure the reduction in light intensity caused by grease coatings on the sensor. The dimmer the light shows the urgent need for maintenance. This automated approach allows for precise monitoring due to the timely alerts. I'll pass my time on to Jia Sheng to talk about the remaining components.
Thank you, Justin. The 4th component will be the LED. It will take data from the temperature sensor and will light up continuously, which serves as a visual aid for the users when the temperature is unusually high. The 5th component will be the buzzer. It works just like the LED, but it will buzz continuously when the temperature detector is very high, alerting the user and people nearby if there is a fire. Finally, the last component will be the LCD. It's the user interface that connects the user and the system. It presents information such as warnings or alerts in a clear manner in a kitchen environment. Now I'll be passing my time over to Benjamin Lee.
Thank you, Jia Sheng. For our key innovations, we have 2 unique features that are currently not out in the market yet. First, we have our light sensors, which helps to accurately detect grease accumulation. With grease accumulating over the sensor, it will cause the sensor readings to drop, and based on the threshold we set, it will then trigger the user to clean it. Currently, there are no affordable solutions out there to achieve these functions at home. There are existing solutions, but they are mainly used for commercial and are very expensive. Next, we have the alarm and automatic shut-off mechanism triggered by the temperature sensor. It will trigger the stove to turn off and alert the user. This is an immediate response to the cause compared to conventional alarms. As for our challenges, there are 2 main issues that we face when implementing this system. First was the connectivity issue with MQTT, as initially there was issues with setting up multiple subscribers to the same field. And then, setting up the LCD with 2 subscribers, we found it challenging to subscribe to 2 different publishers at the same time. Now I'll pass the time to Kenneth to wrap up the presentation.
Thank you, Benjamin. To wrap things up, The 3 key achievements of the project will be the flexibility of the system, minimal delay for the relaying of information, as well as the reaction of our boards are all synchronized. 2 areas of improvement will be to integrate our system with a full-fledged smart home system targeting multiple issues at once. Next, it will be to ensure that there's a faster response time in the smart home system. This ensures that information can be relayed in an orderly manner. With that, I conclude the presentation for our group. Thank you.